Now let's continue solving square root equations with unlike terms. And recall that we have three different flavors for our square root equations. If we have a single variable term or factor, then using the two-column tables are our best approach. If we have a square root term on both sides, and that's all we have, then we can square both sides and proceed. We worked on that technique in the last video. In this video, we're going to concentrate on situations where we have one first degree term and also a square root term. Now, the strategy in a case like this is going to be to isolate the radical term, then square both sides, and then finish solving the equation. For instance, here, my first step would be to subtract x from both sides. That will isolate my square root term. Now I'll square both sides. On the left, I'll simply get 4x plus 1. On the right, you have to be a little careful, because at first it's common for people to want to make 25 minus x squared, but that's wrong. Remember that this difference is our base, and we're multiplying two of these factors together. When we do that by, say, foiling, we'll get 25 minus 10x plus x squared. Notice now that I have a quadratic equation. I can use zero product method. I can use the quadratic formula. I'm going to try the zero product method first because if it works, it's faster. I'm going to subtract 4x from both sides and subtract 1 from both sides. That will set my quadratic expression equal to 0. Now I'm looking for two numbers that multiply to 24 and adds to negative 14. What comes to mind is 12 and 2. And if they're both negative, then I'm going to get x squared minus 14x plus 24. So this looks like a good factored form. I can now solve and find two solutions, 12 and 2. First, I'm going to check 12, and you can see that that doesn't work. So I'm going to have to get rid of 12. Now I'm going to check 2, and that does work. So 2 is my solution. Try this one. First, we'll have to isolate the square root term. Now, one way to do that would be to subtract 3 from both expressions. There's nothing wrong with that. Another approach would be to add the square root of k squared plus 15 to both sides and subtract k from both sides. That's just another approach, and I think I'll take that one. Next, I square both sides. Remember on the left to FOIL. On the right, we'll just get k squared plus 15. I have a quadratic equation, so I'm going to try to bring all my terms to one side, because I need to do that whether I use zero product method or the quadratic formula. And what I find is I'm left with just a linear equation. So I solve the linear equation, and I'll get negative 1. I go back and check. It works. So there's my solution. How about here? I've already isolated my square root term, so I could simply square both sides at this point. But I notice I have factors of 5 throughout, and so I'm going to begin by dividing by 5. Now, you don't have to do this, but I like working with smaller numbers. And you've got a lot of time in now with algebra, so if you can see things that might save you some time, it's good to use them. I'm going to divide by 5. This will just give me square root of k plus 4. And I'll think of this as two fractions, 5k over 5 and 10 over 5. 5k over 5 will reduce to k, and 10 over 5 to 2. And now I'm going to square both sides. And you can see things are a lot smaller, so it's going to be easier to work with. I'll get k plus 4. Over on the right, I'll get k squared plus 4k plus 4, because I'll have to remember to FOIL. I have a quadratic equation, so I'm going to bring all my terms to one side. And now I'm going to use zero product method, because I can see if I factor out a k, I'll have two solutions, 0 or -3. I check 0 and it looks good. I check -3 and it doesn't look good, because one side becomes 5 and the other becomes -5, and so 0 is my only solution. And here's our last one. To isolate my root, I'm going to have to subtract 1 from both sides and add x to both sides. Now I can square both sides. On the left, I'll just get x squared minus 7. On the right, I'll remember to multiply two factors of x minus 1, and I'll get x squared minus 2x plus 1. I'll want to get all my terms on one side. I'll begin by subtracting x squared from both sides, and I notice that if I do that, I just have one variable term left. So this is now a linear equation. I might as well just move forward. I'll subtract 1 from both sides, divide both sides by -2, and then I'll check my solution. The check looks good, so I'm done. Well, that will conclude this video, where we've worked with another way to solve square root equations with unlike terms.